we will build our server with Flask and SQLite, an API or application programming interface. It's a set of rules and protocols that allows different software applications to communicate with each other. Think of it as a bridge that enables one piece of software to request and exchange information with another. In the context of web development, what we're doing right now, the backend refers to the server side of an application where the data is stored and processed. The backend manages the logic, database interactions, and other server-side tasks. The API acts as the intermediary between the backend and other applications, such as a front-end web application or a mobile app. When you interact with a web app, it often sends requests to the backend via APIs to fetch or send data. Essentially, the API exposes the specific functionality of the backend to other software, making it possible for different systems to work together seamlessly. And one disclaimer, the intent of this chapter is not to teach you Python or how to write a Flask application in detail. It's about giving you exposure and a feel for what a backend looks like. But working through those examples, you'll gain a basic understanding of how backend services operate, which will prepare you to extend this knowledge and integrate it with generative AI in later chapters. The goal is to make you comfortable with the foundational concepts so you can confidently move forward in your coding journey. Right, now we need to set up our environment. We'll begin by installing Flask and FlaskCore. Just type pip install Flask and pip install FlaskCore in your terminal in your backend folder. Next, we will set up your project directory. It should look something like this: a backend folder with app.py and modetracker.db. Now let's create a basic Flask application. This code sets up a simple server, import Flask and FlaskCore, initialize the app, and run it in debug mode. And that's it. You've set up your first Flask server. So now we're going to create a file called moontracker.db. First up, we import the SQLite 3 library and connect to our database file. If the file doesn't exist, SQLite will automatically create it for us. Next, we'll create a cursor object. It is the go-between for our code and the database. It's what lets us execute SQL commands and fetch data from the database. Here's where we get to the fun part, creating a table. We use a SQL command to create a table named mood entries. The create table command sets up a new table if it doesn't already exist. Inside this command, we define the columns for our table, like date, journal entry, and more. And you've seen those entries on the application. Each column is set with specific rules, such as data types and constraints. For example, we set date as a unique field, meaning each entry must have a different date. If a table with the same name already exists, the command will not create a new one. This avoids overwriting your data. So once the table is created, we comment the changes to the database to make sure everything is saved, and then we'll close the connection. And there you have it. We've just set up a SQLite database and are ready to start storing our mood tracking data. Right, I have shown you once how to run the backend, but I'm going to redo it because it's so important. You've got your Gitpod workspace here. Use that to run your application. When you do this, you can stay on the browser. You don't have to open the desktop version. It's just a few commands that we want to run on the terminal. When this is open, then you can install your requirements here with this command, pip install -r requirements, and then you can run your application with Python app.py. But in order to do this, you have to be in your backend app folder. I'll show you in a second when the terminal is up and running. So cd backend app, then pip install -r requirements. So when the requirements are installed, the -r requirements are actually here. So you've got it ready, which are Flask and Flask CORS. After the requirements are installed, then I can say, now, Python, please run this out for me. When you do this, then it gives you a URL. So here, and it says a service is available on port 5000. Where the URL looks like something like this, you just have to replace your token here. The token always changes. But like if you don't use the Gitpod workspace and you run this, the same thing here, on your local machine, on your laptop, you get localhost on port 5000. That's where your backend is. In the next slides, you are going to see how you can, develop some functions for your endpoints and what the URL is for your endpoints. But like endpoints, it's just a concept that you probably don't know just yet, or some of you might know, but we'll get back to this. But the most important part of this slide is how to run your backend on this link or this one. So there are two key concepts that I want to talk about first. The first one is CRUD, the other one is endpoints. When we talk about APIs, we need to know about these two, REST APIs. So CRUD stands for create, read, update, and delete. These are the fundamental operations we can perform on data. For this part, we are focusing on read, which means we are retrieving data from our database. Now, what exactly is an endpoint? In web development, an endpoint is a specific URL where our application can retrieve requests and send responses. Imagine it as a door to your house. It's where people come to get information or drop something off. In our Flask application, we're setting up a GET entry endpoint. This endpoint is set to handle GET requests, which means it's designed to respond to requests asking for data. So you go to this URL. I'm just going to zoom out a little bit, zoom in. You can see what you get from this URL. So this is an endpoint that looks like this. So this is your endpoint here on your browser. And when we type this address into our browser, it's like we are asking our application to find and show us the data it has stored for the date, July 1st, 2024. The application then looks into its database. In this case, it's in SQLite database, finds the data related to that date. So this is what I found. And then when I found the data, then it sends it back to you. So you can see it in your browser. And let's look at the process, how it works. Let's go back to the slide. So always you have this. The first line is always when you want to define an endpoint in a Flask. You've got this at app.route, which is defining your endpoint GET entry. And then you've got your date and your method is GET. And then you have connection to the database. We start, within your function, within this function, first of all, you connect to your database. We start by connecting to our SQLite database and creating a cursor object. The cursor, you know what it is. It acts like a middleman between our code and the database, allowing us to execute SQL commands and fetch data. Then we go to the select command. And we use the select SQL command to fetch data from the merge entries table. The select command retrieves specific columns of data based on a condition. In this case, we are selecting data where the date matches the date requested by the user. So we've got the select, tells the database what columns we want to retrieve. So journal entry, triggers, sleep duration, or whatever. And then we've got from, which specifies the table to retrieve the data from merge entries from that table. And we've got where, which is the condition that filters the results to only those that match the specific date. So where, date, quotation mark, and then we've got a date here. And this date comes from our function. And then we have the fetching data. So the cursor executes the command and fetches the matching entry from the database. If an entry is actually found, then it's returned as a JSON object. So this is the JSON object. So we always return as a JSON object. JSON is the way that we communicate. It's just like sort of like the way that it is here. So in a bracelet, you've got activity, which is something, date is something. It's almost like a dictionary. So JSON is a format that's easy to use in web application. If no entry is found for that date, we respond with 404 status code and a message indicating that no entry was found. Let's try this. Let's try for a date in the future, which we don't have anything. So we get this, no entry found for this date. So, and that's how we use the select command to get data from our database. So this is when we couldn't find it. Yeah, and then we can provide this through our endpoint. It's all about making sure the right information is available when someone asks for it. Before going to the next slide, I want to show you the URL because I realized that I didn't actually show the URL. So this is the URL for that entry. And it's, as you can see, is an HTTP request, and it's running on our local host or local machine, port 5000. Get entry is the function that we are having here, and we are actually defining with this decorator. And this is the date that this is the variable of this function here, declared here and here. And then we also mentioned that this method is get. Then it gives us this URL. And this URL takes us to this JSON file, or to this place that we can see the JSON file, the JSON file as a response to our request. So now we're going to set up a get monthly data endpoint to retrieve all journal entries for specific months. And this is the URL that you can see is get monthly data for this specific month, which is July from 2024. And then this is the months variable here, which is a months variable in the function. This is the name of the function. You can change it to anything, like it doesn't have to be the same name as the function name. And your method is get again, because you read data. So in order to do this, the same thing, first we connect to the SQLite database with the cursor object, and then we run an SQL command. So this is a SQL command that we're running, and to get the data from the mood entries table where the date matches the requested months. Now to match the months, we're using the strftime function. strftime is a handy function that formats dates as strings. Here we're using it to format the date as y, like 4-digit y, which is like a 4-digit year, -mm, 2-digit months. So we can easily filter entries by months, because we're saying where strftime of date in this format is the question mark, which is filled by months variable. So after executing the command, again, when we fetch data, then we close the connection. And then we have to process the data. We create a list of objects, actually, the list of dictionaries. Why is that? Because if you go to your URL, so to that URL for that specific month, it gives you all the data that it has for that particular month, 1st of July, 2nd of July, and it's like a list of dictionary or a list of JSON objects. And then 4th of July, and keeps going on to the end of the month. And that's why we've got a list here. So we've got a list here and bracelet, and then you can just get the data, process the data, every entry that you have for date, for journal entry, triggers, and then you can keep going. And then at the end, you always return this data as a JSON response. I have to mention here that we're not only developing get methods, we've got post methods too, like something that you see here. For example, imagine that we've got one of the users entering some of the data in one of our forms, and we want to actually store that data. Then we develop this save entry function with this decorator that shows the entry point as save and the method as post. And the first thing that we have to do is extracting the data. And the data that we are extracting includes information like the date, journal entry, triggers, sleep duration, and other details that we want to store. Then the same thing that you have seen multiple times as connecting to the database and creating that cursor object. Then we have the SQL command. This is our SQL command, which is insert or replace. And this tells SQLite to insert a new row into the mood entries table. If a row with the same primary key, in this case is the date, already exists, it replaces the old row with the new date. And we've got this values question. And this part specifies the actual data to be inserted or updated. The question placeholders are used to safely insert values into the SQL command, preventing issues like SQL injection. So we've got those question marks, then you've got they are going to be replaced by those variables that we have extracted before, date, journal entry, triggers, and sleep duration. And as we've seen before, then we have to commit our changes and close the database. And the last part is, which is important, we need to return a success message in JSON format. This lets the user know that the entry has been saved or updated successfully. And we handle saving or updating entries in our database in a way that will make sure our mood tracking information is always up to date. Those are two important things, CORS and testing our APIs. CORS stands for Cross-Origin Resource Sharing. It's a security feature in web browsers that restricts how resources on a web page can be requested from another domain. If your server needs to be accessed from web applications hosted on different domains, you will need to enable CORS. To enable CORS in your Flask application is super easy. You just need to add a couple of lines. You can see it here. First, import CORS from the Flask CORS package, then initialize CORS by passing your Flask application to it. So you can see this part here that you pass it. And then this will allow your server to accept requests from different domains. Now onto testing our APIs. You can use tools like Postman or Kill to make sure everything's working as expected. For example, here's how you can test the save entry endpoint using Kill. This command sends a post request to our API with a JSON payload. You can see it here. So that's a post with a Kill command. And then you can see that it's a JSON type, the application, and this is the dictionary that we're sending to this save entry. And what would happen is you provide the date, journal entry, triggers, sleep duration, and other details. If everything is set up correctly, you should see a response from the server indicating whether the entry was successfully saved. So this is how you can test with curl command, or you can use the browser. It's up to you. Rightio. No matter how many times we walk through the code together, the real magic happens when you get your hands dirty. You can always refer back to the code examples, but to truly understand and master the concepts, you've got to start building yourself. That's why I've got an assignment here for you. It's your chance to take everything you've learned, put it into practice, and see how it all comes together. This is where you turn theory into skill. So let's get started. Your task is to extend our Mood Tracker app with a couple of new features. First, create a new endpoint that lets you delete a journal entry by its date. But here's an additional challenge. Make sure to add validation to check if the entry actually exists before you attempt to delete it. This will ensure that you don't end up with errors or try to delete something that isn't there. All right, and have fun with this, and don't hesitate to reach out to your Bytes and Balance community.